Sorry, guys, there are no breaks, okay? That was the first suggestion. Anyway, great group, no defectors, okay, in our group. And you can see from the photos there that we had people from industry, software industry, Ted Black from Sandia National Labs, and etc. First, you know, a potential game changer was, and I can speak, you know, from experience of that. I'm early adopter, so I jumped to these projects, and sometimes they're very successful, and we're very happy, and sometimes we get burned because the tools are not there. One of these examples is integration of modern topology optimization and additive layer manufacturing, because it has enormous potential for lightweight designs. Okay, so additive manufacturing has been here forever. Look at the pyramids, for example, in Egypt. Okay, so it's not a new technique, all right, but now what happens, and we had stereolithography forever, and we had prototypes, and it was cool to bring them in a management meeting and etc. But now we have a 3D printing metal, in high-strength metal. And we have some excellent examples. Go to SpaceX website and see an engine we work really hard for, and it's beautiful. It takes 24 components and make them one, and you don't need bolts and nuts and flanges, and you have all the passages, and you can distribute well the flow, and etc. So there's enormous potential. So why don't we, everybody's using it? Well, try to use the conventional CAD tools to create a lattice structure. We have these cell features in parametric models, and you say remove that surface, hollow this part out, and it puts only air in it. You don't have the ability to say, okay, hollow this part out, but fill it up with a lattice structure which looks like the tetrahedron, and it has that spacing in the x direction, that's in the y and that's in the z. Okay? So we had to struggle with workarounds to do that. So CAD is not ready for that. So, and then optimization tools can handle the massive free-form lattice structures. And what is really funny, I remember specifically when I was so excited the first time I played with a solid model. So I built the part, hit the deep hole, another deep hole, and another deep hole, and all the flow was beautiful till you take it to manufacturing. And they look at it and say, oh my gosh, how will I build this? Okay, so in the past, we could design parts, we couldn't build. Now we're on the other side. We can build parts we can't even design because the CAD tools are not there. You know, so anyway, so that was one potential game changer. I know all the software vendors are working on that. They promise us, we keep pushing them from the CAD vendors, CAE vendors, topology optimization vendors. The process is very broken because from topology optimization, you get STLs, and then, you know, that's the problem. The vendors tell you, okay, you got a topology optimized part, just file, print, preview, print. Yeah, but I can't give to the customer, if it's DOE or defense industry, an STL part when they need to do, for example, tolerance analysis or tolerance stack-up, or to put, you know, GD&T on it, or to know where the ball bearings are with accuracy, and etc. So very broken process. The topology optimization straight to printer is not quite, you know, acceptable yet. But look, we have, from the photos, you can see we have really fantastic designs. We can save up to 70% of the weight, you know, not 70. Of course, another topic was design process automation, take the human completely out of the loop. We have an enterprise transformation, front-end architecture. You say, I want a 4-passenger car, and then the system selects the engine, the powertrain, the suspension, the body in white, and etc. We're not quite there yet, but there is the potential to do that, to have high-level requirements and have captured the knowledge of the experts, you know, which they know. If you go to an expert and say, I have a 4-passenger car, it's like a neon-sized type, he says, oh, you need to use that engine. He had some thought process, but we don't have captured that, so we can do this high-level design automation. Another groups talked about it, simulation in the web, cloud, and mobile. Internal cloud simulations are available for years. Yeah, I remember when we used to have, the supercomputers, the IBMs, and the digitals of the world, and we submit the job there. Public cloud simulations are new and exciting. Why they're new and exciting? Because you can scale. You don't need to have the license for, 2,000 processors to run a Dyna simulation or a large CFD simulation. You can scale as needed. So HPC scaling, you don't need to worry about software updates, especially for small, medium enterprises. There is a nightmare to synchronize the new version of the simulation software. Does it talk to the CAD software? No, the interface is not there yet, so hold on this one till they start talking. It's a nightmare. This thing can pass to the cloud, installation, and of course, IT cost. Another new and an exciting potential game changer is what we call the birth of digital twins with CAE and Internet of Things, okay? The customers of large systems, they don't ask you the delivery of a rocket, for example, or an airplane. They want a highly detailed digital model. We call it digital twin, specific to that particular rocket. So it follows through the life of the product, the bill of materials, and if you change the motor, if you change something, and then, even more important, it's a health, you monitor the health of the system, okay? For example, if you have a rocket and somewhere it vibrates a lot and the fatigue loads are very close to the limit, you say, okay, let's stop and change the mission profile so we can bring it slowly down because that particular component is ready to fatigue. As simulations and analysts, we used to always do something funny. We have a CAD model, we mesh it, and then we apply a load. And where does that load come from? If it's in automotive industry, we have very specific requirements, put 4G at the front wheel and 2G that way and 1G that way to size the components. Now with digital twins, we don't have to have the simulation, the analyst guy to specify the load. You have the physical twin saying to the digital twin, that's what my load is. So you can real-time loading, but the simulation software is not built like that. I can say to a Nancy simulation, the load which is applied at that spot and is in that direction comes from channel number 5 from the digital twin. They're not built to do real-time CAE all the time, so you can monitor the health of the system. But it's getting there because the sensors are cheaper. With the Internet of Things, you can monitor stuff. You can say, in a Caterpillar tractor, the 5th gear is having this funny vibration, so it's going to break. Can you please ship the gear there? But it didn't break it. Let's just ship it, it will break, So the physical twins communicate to the digital twin, and the digital twin says to the, vendor, can you please send him gear number 3 because there is an issue or coming up. So it's really enormous potential. Okay? And even more with augmented reality. I don't know if augmented reality is, you see it all the time on football, okay? They put the line, on the 10-yard line, and so you know exactly where the things. I was always amazed, how can they do in real time? They know exactly where the line is. But now we can have the same thing, augmented reality, because you have the digital twin and you walk in close it with your tablet and you can see the real-time video, but you can superimpose on it things you want for serviceability or changing something and say, open this door and do these things, which is great because for software vendors, you guys have another use of CAD data to put them in augmented reality type software. Another one was gaming industry. The gaming industry is so much ahead than the CAD and CAE industry. Our kids can go to different worlds and they collaborate very well. They have no problem of collaboration with other people to do teamwork. You know, they have sometimes the mics and the speakers and they talk to each other, but you know, they collaborate very well in the virtual world and they can be all over the universe. So why don't our industry get ideas from there for collaboration or crowdsourcing? You guys work on this part of the component, you guys work on this component, or like our kids do, they give high fives when they go to another level. I'm level 20 on that game. Why don't we do the same thing? Okay, you have level 1 for structural analysis, now you can do thermal, you can do multi-physics, and etc. We can have a gaming industry type certification to quickly certify our users. Of course, we had the diverse group, so model-based system engineering was a topic, something we can have a data structure for system-level models and the system architecture, so we can have design justifications. Why did we choose that design? So really capture the lessons learned from the previous design process on system level. And uncertainty, capture the uncertainty in requirements. Hopefully the digital twins, they will narrow that. I mean, I remember when I took my sabbatical at Ford, I was asking, where did you come up with that 4G static load to design the suspension? And that's, well, shut up and just do this. You know, we do this for a long time. No justification. Somebody had it, I guess it worked, and they do it. But can you go 3.5G and make it lighter and equally strong, and you don't need that? Don't over-design it. So another big topic was knowledge capture and reuse. We need reusable design process. In abstract modeling, we have seen efforts, you know, from Comet Solutions and other companies for abstract modeling. Abstract modeling means do simulation start the simulation before you have the CAD model. So how can I do that? I don't have a mesh and stuff. You can have a representative CAD model and say the inlet velocity is here, the outlet is here, give names to these surfaces, and the heat load comes from the top, give it that heat load 1, 2, and then when the real CAD system comes, you reassign automatically because you have named these surfaces. So all the other stuff, like element sizing and flow properties and iterations and setup, they're all set up so you can very quickly, with an abstract model, re-execute an existing model. So capture the intelligence of the people they did that previously. So artificial intelligence in design tools and knowledge-based engineering. Good examples are like GDT Advisor. It doesn't let you do dumb decisions when you select something and you try to apply something which is different. Okay, don't have the system, don't let me, let's say, apply modulus of elasticity doesn't exist, or yield stress, it's not in this universe, or something like that. So embed artificial intelligence in the CAE tools so they can be more effective and avoid mistakes. And knowledge must be managed globally. And the last one, I think, was computer-aided innovation. There are 4 topics there. Some of them are dear to my heart, and I use them daily, like theory of inventing problem solving, use trees to not try to improve a design, make the thickness a little bit better and the width better, but change the conceptual design. Evaluate your conceptual design from scratch. And we have a lot of tools. They help us analyze mechanisms, but they don't tell us what the mechanism needs to look like. So mechanism synthesis tools, there are tools that are available, but they're not widely used, and people don't know about it. Material selector, and of course, material selector is from Cambridge, a very nice tool which you specify, I want bending and axial, and said, those are good materials for that type of arise, and ShapeFinder, which is similar to topology optimization. I think we have plenty of time now for questions. Is that right? All right, thank you.
Do we have a question for Andreas?
Good.
Oh, go ahead. Okay, Brad.
So, Andreas, you mentioned IoT. Do you know when we first talked about IoT here at COFES? It was in 2007, 9 years ago, at Bruce Sterling's keynote. So the question is, for these game changers, can you scope which ones of these are near term and which ones of them are we going to be talking about at COFES 2025?
The IoT is there. It's coming.
After 9 years.
After, well, yeah, and it's not for everybody also, okay? But what happened, there are some revolutionary things. There is something Raspberry Pi computer, which is very low cost. It can get the data acquisition stuff. We tape it with duct tape, okay? We did the project with NASA. We had to use duct tape to hold that computer there, but that was able, with, I don't know, less than $100 to have the computer which takes the data acquisition stuff and sends them there. Now, the aerospace industry, like at SpaceX, there are about 20,000 sensors every millisecond sending information. So another big problem, they're big data. The data are coming so fast and they're so massive, you need to have back systems to just monitor. A human cannot quite do that. So the answer is some of these technologies need to mature, and it's really cost what makes them happen. And now we can see a lot of even CAD vendors, all big 3 CAD companies start to acquire data analytics and IoT people and virtual reality and augmented reality and all these things. So eventually they will happen. We just were ahead of time, the vision.
But for these things that we're looking at on the list, how far out are they?
Well, it depends which one. The Shape Finder, if you can see, Autodesk is introducing these things. Altair is introducing a really nice product called Inspire and Evolve, I think. All major CAE vendors start to embrace topology optimization because now you can 3D print these weird organic shapes. So that can happen. Mechanism synthesis is already there. I don't know why the software vendors have not embraced it, and they give us only analysis. You give me your mechanism, I'll tell you the forces and accelerations instead of, I'll give you the mechanism. Tell me what you want to do. I want to take the part here, 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 here. Oh, where can you support it here? Those are the mechanisms. They can do it. Theory of inventing, problem solving, there are 2 companies, they do that. They're almost out of business, like Invention Machine and Ideation. I use one of them. They're very effective for conceptual design, very hard to convince the management that I have a tool which will enable you to do innovation. They don't quite believe it. After you explain them or you demonstrate it, it happens. I can tell you SpaceX is an early adopter. We work a lot. Whenever they have a new problem, instead of saying, how did the rocket industry solve that before, they say, let's go through this exercise first. So you need the management to be inspiring and have good culture, excellent culture to do these things. So some of them are near term, some of them, I guess, if we take the presentation, we will see it in years down the road and it wouldn't be quite there. But IoT, it's coming. It's almost there. The big companies are using it. The aerospace use it for a long time, although sometimes we lose planes and we can find where they are. But you know, now we get smarter and we put more sensors, so we will be able to track where things are and what are they doing, what loads they get.
So perhaps next year we can have a report on the progress on these game changers.
We could go through all of them and see which ones are exactly the same spot, and some of them I can guarantee you they will be ahead.
Well, thank you, Andreas.
Thank you.